Okay, we are online. Yes. So we can start the session. So Shan, please.
All right, hey everyone. So I'll be talking about 3D tiles and glTF. So this is sort of an intro. I think some people might already be familiar, but I'll give a quick rundown of what these formats are and how they're sort of co-evolving. So first, I'll just give some background on Cesium. So I work at Cesium. We just became part of Bentley Systems, well, 2 years ago. And we deal with 3D geospatial. And often 3D geospatial data sets are very massive. And there's a lot of different types of geospatial data. But we notice that there's some common themes. So like data is georeferenced, massive scale, heterogeneous, meaning there's many different types of data. And then often they have semantic metadata associated with them. So 3D tiles supports a bunch of different data types. So like 3D buildings, point clouds, photogrammetry, vector data, voxels, instance models, and global train and imagery. And then in terms of the two formats we're talking about, so 3D tiles is an OGC community standard that defines spatial subdivision and the georeferencing aspect of the data. And then 3D tiles references glTF. glTF is a 3D model format from Chronos, and that's what contains the geometry and textures and the compression and the semantic metadata. And so you have really 3D tiles is like this tree of tiles, and every single tile is a glTF. So that's the current relationship between these two standards. Another look at that. So 3D tile supports what we call bounding volume hierarchies. So this is the ability for a tile to have a bounding volume, and then its children have bounding volumes, and you create this tree of bounding volumes. And then every single tile will have other properties in addition to the bounding volume, including a geometric error, refinement type, and some other things. And 3D tiles is meant to be fairly flexible. So like often in geospatial, there'd be like 2D tiling schemes, and they're usually like fixed tiling schemes like quad trees. But 3D tiles, you can define very explicit bounding volumes and support a wide variety of spatial data structures. So we do support quad trees as well as oct trees, KD trees. On the bottom left, we call like a loose quad tree where features can actually span across neighbor tiles, and you can like extend tile boundaries so that they cross over a little bit. And then you can also have like sort of more clustering type techniques. Really, the idea is just that you have bounding volumes that are just contained within other bounding volumes. 3D tiles also has the concept of hierarchical level of detail. So often you'll have like a root tile that has the highest error, and then its children have less error. And eventually you'll hit a leaf tile, which ideally is the source truth, like the source data, and it would have a 0 for its geometric error. And at runtime, we convert geometric error, which is like an error in meters, to a screen space error, which is an error in pixels. And so like this picture here, like the pink is like the highest detail, the green is like the root tile, the lowest detail. And when you convert that into screen space error, you see that there's about 4 pixels error. And if a client says, like, if there's 4 pixels error I want to refine to my children, it'll do so. And it'll start to load the next set of data. And now it'll be 2 pixels error, which will be sufficient for the client in that case. And then, so this all comes together into like how to select levels of detail. So showing this little code snippet just to show that you can almost write a 3D tiles traversal with very few lines of code. Now there's a lot of complexity ultimately, but essentially you compute the screen space error based on like where the camera's looking, how far away it is from the tile, and that tile's geometric error. And then you compare the computed screen space error with a maximum screen space error that's defined by the client. And if it's less, then you select the tile. Otherwise, you have to load the children. And that's absolutely the most basic. And then there's other optimizations on top of that, like frustum calling, skipping levels of detail, doing tile request prioritization and preloading. So those all are sort of optimizations that you can add on top. Just a little bit about different culling techniques with 3D tiles. So you have frustum culling. So your camera's shape of a frustum. Any tile outside of that, you don't have to render or even to request. So you can just not do anything with that. And the camera will actually just see the tiles like this, and it won't see what's behind it. So that's one type. Then there's occlusion culling, where you may have data that's like in the foreground that's blocking data that's in the background, and you don't want to make those requests for the tiles in the background if they're not going to be visible. We also have these are more, I'd say, geospatial. The first two are very like 3D graphics fundamental. The last two are more geospatial focused. So we have like fog culling, where in CSMJS and other runtimes we have like a fog, and so we increase the screen space error the further away it is, the more in fog it is. And we also have horizon culling. So if a tile is deemed to be on the other side of the globe, we don't make a request for it. Also, 3D tiles is very centered on precision, making sure that it can represent the Earth at full scale. So the Earth being about 6 million plus meters like range, we need to be able to support that in 3D tiles and also in our clients. So we have a couple different approaches for this. I think the key one for 3D tiles though is the vertex precision. So like basically all the math that we do in terms of like doing tile transforms is in 64-bit on the CPU. And then we eventually, once we do like the model view, like transformation stuff inside the CPU, we convert that into 32-bit matrix, and that's relative to the eye. And all the vertices are 32-bit floats relative to that. Also, I realize I'm probably getting too much into like the low-level engine and graphics side, but these are all just fundamental concepts of 3D tiles and maintaining precision. Also, compression is a very important topic since we have these very large data sets that can be gigabytes to terabytes of data. Compression is really important. So there's two types of compression that we deal with. One is geometry compression, which there's a few different techniques, and there's glTF extensions for each of these. And then there's also texture compression, where probably the most interesting one for us is KTX2 and Basis, which is a GPU compressed format that stays compressed on the GPU. So you can have basically up to 1/8 of the GPU memory, as you would if you had been using JPEG or PNG and decoded that to just raw pixels. So KTX2 is, especially for some of these photogrammetry data sets, is just a real nice format for us. I have some stats here for compression. So for this data set, this is a photogrammetry model, 2-centimeter resolution of downtown San Francisco. We got 82% smaller file size, so on-disk file size, 81% less GPU memory usage, and 48% faster load time for this using these compression techniques. And then some other things that we do with 3D tiles for optimizing is we do something called batching, which is when you have a lot of different features that are in the same tile. You don't want to render each of those features individually because then you'll have a lot of draw calls, which is very inefficient for the renderer. So we try to batch all the geometry that we can together, and we add a separate vertex attribute called a feature ID attribute that stores the IDs. And then you can use that feature ID later to either be able to select something or to write a style that controls the color of it. But it can still be a single draw call, which is really important. So ultimately, our goal is like a single tile should be as minimum draw calls as possible. Ideally, one. It's not always possible if they have different materials for some of the buildings, but that's our overall goal. And then we also do things like instancing, often comes up with tree models. The GPU has just built-in instancing support, so we try to take advantage of that. And then I think finally, so metadata. Like we have all this geometry and texture information, but we also want the ability to encode properties into these data sets, whether that's per feature properties or like it can also be potentially per texel properties. So like this example here, we have a mesh that has a secondary texture that is the uncertainty value, the local uncertainty and the horizontal, or the local horizontal uncertainty and the local vertical uncertainty encoded in a texture. And we need to be able to like query it at runtime. So there's a few different ways that we encode metadata within 3D tiles and glTF. All right, so that's the very fast intro of the current state of 3D tiles. So I guess what we could call like 3D tiles 1.1. And then we're currently in the process of defining 3D tiles 2.0, which is actually one of the major themes of the code sprint as well. So some of the what 3D tiles has looked like over time. So it started in 2015. That was like the 0.0 version. Became a community standard in 2019. That's when we released 1.0. And then in 2023, we did 1.1. And so in progress, a few different features that I'll touch on. So first is we have some new content types. So I talked about like photogrammetry, BIM models, point clouds. Those already existed, but now we're adding support for voxels, so for subsurface data and scientific data. We're also adding support for time dynamic 3D tiles, so 3D tiles that can change over time. We're also adding support for vector data, so that would be more traditional GIS type vector data. But we have a big emphasis on 3D vector data as well. So it's especially like if you're trying to model, for example, like cracks on the side of the building or the side of a structure, like 2D vector formats aren't necessarily going to be good enough because they'll sort of slice through it vertically. But if you have like vectors along the side of a wall, you need to be able to represent that with true 3D. And then finally, a new content type that we've been working on and is already in production is a 3D Gaussian splat for 3D tiles. All right, so I'll touch briefly on each of these. So voxels, these are two examples from Swiss Togo. So they do like underground, basically underground material classification for Switzerland. And so they're storing basically a per voxel like rock type and other information. We have a few different bounding volume types that we support. I think the two most common ones are the box and the ellipsoid format. The cylinder is used for some like radar systems. But typically, so there's a lot of other voxel formats within the graphics community. They're usually based on boxes, but ellipsoid is really important for the geospatial use case. So we support that as well. And the math is a lot more complicated for ellipsoid. All right, so then time dynamic tiles. So this allows every tile to have multiple contents associated with it, and those contents can have timestamps. And this allows you to have, if there's an area of the site that's changing frequently, that'll have many contents, but there could be an area that doesn't change at all. It'll just have a single content. And this essentially just built on top of the existing 3D tile structure. And because the existing 3D tile structure is like supports like sparse data, time dynamic is the same way. You don't have to have a timestamp if you don't need it for a particular tile. And then vector tiles. Yeah, we're adding support for vector data into glTF, and then that'll make its way then into 3D tiles. Yeah, and there's this one. There's a few different ways that we've considered doing this, but we're kind of taking an approach similar to maybe like MapLibre tiles, where it encodes both like at least for polygons, it encodes like the edges as well as the triangulation. So if you have a client that just needs the triangulation really fast and you don't want to do that on the client, you want the generated tile set to have that in advance. That's one use case we have. All right, and then Gaussian splats. This is really good for data sets that traditionally don't work as well with photogrammetry, either because it has like either thin structures or a lot of foliage. Gaussian splats typically does a better job of representing that type of data. And it fully supports level of detail as well. All right, and then we also have a few extensions that are more, I'd say, BIM focused. So one example is edge rendering. So we have a couple extensions to support drawing edges on models. These are glTF extensions. And so as opposed to just drawing the edges of every single triangle, you're actually encoding like which are the important edges that need to be highlighted. We also have some line style extensions, which are also important for BIM. And then some other extensions. This one's a constant LOD texture fill, so that you can have like a repeating texture that looks as if it's a constant level of detail, regardless of your zoom. And also planar fill style. I think this one's important for more of these architecture drawings, where you don't want Z fighting of the letters versus the underlying plane. All right. So, and where we're heading for 3D Tiles 2.0 is, so a lot of what I've talked about is like 3D tiles is sort of this separate spatial subdivision structure. glTF is the asset format. We're actually kind of bringing it together where glTF 2.1 is going to be receiving some of the capabilities that 3D tiles has. So we're planning on adding support for essentially complex scenes in glTF. So glTF will have the ability to represent bounding volumes. It'll have the concept of level of detail, and they'll be able, a glTF will be able to reference other glTFs. So these are very 3D tiles-like capabilities that we're bringing into glTF. And the reason we're doing that is because 3D tiles is very widely used in geospatial, and there's a lot of people who would benefit from its capabilities, especially within the broader graphics community. And the broader graphics community is kind of all like very much in glTF and understand glTF. And we think in order to get greater adoption of like massive models, massive model rendering, geospatial, is to bring more of that into glTF. So that's where we're headed. And 3D tiles would still exist as sort of its own profile, if you will, of glTF 2.1. So it'll still have the geospatial aspects. We're not trying to bring geospatial aspects directly into glTF. We still want to have 3D tiles as a like a wrapper layer almost that has the geospatial aspects of it. But this is still like a pretty fundamental shift. We're still working out the details of it. And that's our focus of the sprint, I think, is trying to really nail down like glTF 2.1. What capabilities go in core? What are extensions? How can we make it future-proof as much as possible? All right, I think I probably already talked about all these, but yeah, like 3D tiles fits in the middle of these concepts. But then there's people that are using that would, I think, benefit from 3D tiles, but don't need maybe all three. Like IKEA is doing a bunch of stuff with very similar level of detail approach, but they don't need bounding volumes necessarily for this. So they might take advantage of these two features. And we think actually all of these, like, there's use cases anywhere in this Venn diagram, really. So what this means for the community, so 3D tiles being sort of baselined on glTF, there will be fewer formats, clearer patterns, more reuse. There's some struggles today with, like, for example, coordinate systems, like glTF is Y up, 3D tiles is Z up. That would go away. It would just be probably Y up, glTF system. And there's even terminology that's very similar. Like 3D tiles calls it a tile, glTF calls it a node. 3D tiles calls it a transform, glTF calls it a matrix. But they're the same concept. And they have very similar philosophies overall, just they're trying to be really runtime efficient for 3D. The only difference really is that 3D tiles added that sort of spatial subdivision on top of glTF. But now we're just trying to bring the spatial subdivision into glTF. Yeah, and we think this is just an extensible platform for the next decade or so. glTF is just so widely adopted, the tooling is really good. And we think that's a good home for a lot of the 3D tiles capabilities. So in terms of timeline, so I guess we're at, well, before the June 26th. So we hope to have a justification. Actually, I don't know, this might change, but we're hoping to have the justification pretty soon. Once we have like a first like stable draft spec. And then we're also hoping to submit by like August, October timeframe. Still our goal, but a little bit, basically everything has to go right, which we'll see. And then just concluding with this just slide of who's using 3D tiles 2.0 so far. All these different features I talked about. All right, so that's all I have. So happy to take any questions, even because I realize that maybe not everyone's familiar with glTF and 3D tiles, so even like basic questions are too. But thank you.
Thank you. Yeah, it will be great to have some questions. Yeah.
Yep.
Could you go back and show that time dynamic tile? So it was quite interesting, but I didn't
Sure.
quite understand why I was seeing the green.
Oh yes, yeah. So I can talk about that a bit. Yeah. So this is one of the companies we work with called EarthBrain. They're a Japanese company. So the green data is what's called as-built data. That's what the actual like excavators and other like machines are collecting. Whereas the color data is like from a drone survey. So the as-built data doesn't inherently have color in it. So that's why I'm just drawing it as green.
Okay.
Yeah. But like this is pretty much what you're seeing here is like day by day progress on a job site, but then sped up like 100x or whatever.
Cool. So they collect the data in like much more granular kind of moment by moment as the green kind of highlights.
Yeah. So
And
they'll have like a
then
machine.
every day with a drone or something, or every week or something, to then update the kind of the base.
Exactly.
Okay.
Yep.
Cool. Thank you.
Yep.
I have a very basic one. I don't know if you explain it, but what is a voxel?
Oh yeah, voxel. Yeah, that's a so a voxel, or I guess the etymology of it is like a volume pixel. So it's like a pixels 2D, voxels 3D. It's a box typically. Minecraft
Yeah.
style.
Yeah,
Yeah.
because you were saying box is like, okay, but I see this with V. So it's from volume.
Yeah,
not
volume.
From
Yeah.
box. Okay.
Yep.
Thank you very much.
Sorry, just to add on to that, you also said texel.
Oh yes. Yeah, texel, that would be texel is similar to a pixel, but it's like a pixel in a texture.
Okay.
It would be a texel. Yeah.
So
So I'm wondering, like, when you mentioned the type dynamic, like the one, so have you used, is it like you integrate the shader inside the 3D tiles already, or
So we have, depending on the type of data,
yes,
there will be special shaders.
oh, Office shader already? Okay.
Yeah, and so this one though, this one's actually a fairly simple shader. I think it's more just like the as you're making different tile requests, just new data is constantly coming in. But the shader itself is fairly simple. It's just whatever the point cloud shader is.
I see.
Yeah.
Because I'm doing like more like flooding and also like how structure would change
Mm.
like based on the force or anything. So it actually is quite helpful for us. Yeah, in our field actually.
Okay, yeah, we should also talk more about that use case.
Okay, yeah.
Yeah.
Thank you so much.
As a BIM manager, I will call this, format, which name is 4D modeling. So we add time series data to the 3D models to understand the progress of the project. And I just wanted to check with you, what kind of architecture are you using for connecting this time series format to the components of these 3D models? So could you please elaborate on that?
Yeah. So I think there's a couple ways to do it. One is you could have the data changing per tile. Like you can have a tile of data that could be day one, then day two could be a different tile, and you just completely swap out the content. That could be one approach. That's kind of what I'm showing here. But the second approach could be each individual component could store like what changes have occurred to it. And that could be stored more on like per feature like attributes. I think both approaches are valid. I think it depends. Yeah, it kind of depends exactly what you're trying to do. But yeah.
Yes, exactly. Normally we use Navisworks, for example, for connecting these time series to the components. And I just wanted to check with that. Is there any architecture or API that you are providing for the normal users to connect these time series, data to these components for, for example, an open source platform to connect this?
I know there's some closed source stuff that we've done, like broader Bentley Systems has done to encode time information in design models. I think iTwin Engage is one of the products. And we're sort of in the process of writing the open source code for that. But I don't think we have a server solution that's open source. I think it's mostly 3D tiles would be the open standard. And
So in terms of implementations,
yeah, for implementations, yeah, there is a CSIM.js fork of like this video that I'm showing here. And I guess, and yeah, in terms of CAD, I think I mean, the common way I think that people also do it is like they'll encode a timestamp in every component and then just hide or show based on what's on the timeline. So that could be a very simple way to do it today with 3D tiles, and you wouldn't need, that would be all open source.
Yeah, great. Thank
Yep.
you.
Yeah, maybe if I can comment on that. So I think the use cases matter. So when we're talking about dynamic tiles, time series enabled content, for example, the infrastructure being more, you know, if the asset already has a rich metadata associated with it, and we do this already today, right? Whether it's construction day, whatever attributes that you might have with the asset, time becoming just one of the components that allow you to, you know, sort of like filter also. So at least in the works that we've done, what we've seen is that people want to have all these different parameters that they want to use to sort of filter. And the filtering is not only, you know, you can look at the filtering two ways, right? The filtering you can do for what you're requesting, content that you're getting, and then also during visualization time, what you're looking at. So I'm filtering based on, you know, time. Is this particular use case? And what Sean was describing earlier, you know, you can have to approach one. One could be just filtering the tiles. So each tile has a stamp, but that's more like a bigger kind of hammer because everything in that tile would be on or off, right? And it could work if you're collecting data from drones and that kind of stuff. Typically, you know, that workflow is good enough. But in this kind of workflow, BIM infrastructure kind of stuff, like where every asset actually is being created with the intent of having this additional metadata, just time becomes just one of the assets. And then time would start working similarly as color or as, you know, any of the attributes that you have. So the use cases really matter, you know, when you have this content, you know, content that is captured by drones and that kind of stuff. You know, fairly work okay with this simplistic approach, but infrastructure, BIM, that kind of data has more, there's more attributes to it. So you want to work, you know, per feature.
Yes.
So having those granularity.
Yeah, it's all about granularities. Yeah, because
Yeah.
you can even have like separate tile sets if you wanted. That'd be the highest granularity.
Yes, exactly. So
That's the format solution is like
Yeah,
have hundreds of layers that, and it still works, right? You know, layer A is time whatever, you know,
Yeah.
layer B is time plus 10. So
yes, exactly. If I want to share my point of view as a construction engineer, in our industry, we are really, it is really important for us to track the time and cost of the project. And the cost would be another attribute that we can add to these kind of 3D models as a 5D modeling. And we have a concept which is ND modeling.
yeah,
So this ND modeling is added with different kind of data. For example, if you add time would be 4D modeling, if you add cost would be 5D modeling,
Yeah.
and also some predictive maintenance would be 6D modeling, for example. So just to add add some points around this area, if we could add this kind of data, we can adopt our progress with beam modeling as well, and it would be very good. Thank you so much for your sharing data.
yeah, and at least with 3D tiles, a lot of it is custom, so you can have like whatever properties you want, you could add,
Yes,
and then filter based on those.
great, thank you.
Yep.
So a very basic question. So basically, the data that now it's in 3D tiles, you won't be able to represent it, encode it with glTF, the full capabilities of
We're hoping to have,
glTF 2.0.
yeah, I mean, we're hoping to have like one-to-one mapping of features
Okay.
between 3D tiles 1.1 and GLTF 2.1.
And do you have available like some sample data sets,
We have,
3D tiles that you could share maybe?
yeah, so definitely, there's a, I think my screen is still sharing. There's a
Yeah.
repo called 3D Tiles Samples. We don't have any 3D Tiles 2.0 samples here yet, but
Okay.
this has some very basic, basic examples.
Of the diversity
Yeah.
of use cases that you can.
Yeah, these are yeah, these are some of the different use cases. They're not the most maybe real world practical. Some of these are very like mathematical looking, but they show off different features in 3D Tiles 1.1.
Maybe if there are some people here or also online that have use cases data that you would like to encode, I think that would be useful.
If anyone's like working with point clouds and you need like a point cloud example or BIM data, like I could point you to something. Yeah.
No, I was suggesting if they want to share their.
Oh yes, yeah, that too, yeah.
So we could like use them as test cases for the standard.
Okay.
Yeah.
I have one more question.
Yep.
I think related with the question of Joanna, you were saying that the glTF and 3D tiles, they have some clashes on the semantics, but is this fully solvable? Like all the concepts are one-to-one, or there are some overlapping definitions?
Well, yeah. I'd say there's nothing that's quite clashing yet. Like either there's things that are one-to-one or things that haven't been added to glTF yet that we are adding. Yeah, I think that's probably the best way to put it.
That's very important. Thank you.
Yep.
Oh yeah. Follow on that question, I just wanted to understand if there is any possibility to understand the clashes between these IDs. For example, if you want to, construct a building, which is really important for us to filter some IDs and to understand if there are some clashes between them before the construction phase. So would it be possible for us to filter these, for example, to different IDs like plumbing and the structure and check if there's any clash between them or not?
Yes. Are you talking about like physical clashes?
Yes.
Like geometry? Yeah. At least you could try to visualize some of that. So like we can bring up an example. So I think we have an example here of like category filtering.
Yeah.
It's taking a little while to load. But yeah, so here you can like, based on the attribute information that's in the 3D tiles, you can like just show the walls or just show the floors. I don't know if this is actually per domain, but we also have examples of like the, yeah, maybe this one.
Yes, I think the second one would be.
Yeah, so here it's showing, yeah, I think just like the water system. So you can at least visually see the difference. And then I forget what this might just be radius of the pipes, but yeah. You might need a separate tool to do the analysis, but for visualization, yes.
Yes, great, thank
you. We have another tutorial coming, starting on,
okay.
But I was going to suggest that I think there are a few people here interested in 3D tiles. Maybe we can sit outside and continue the conversation, and even online if anyone is interested in 3D tiles and they want to work on this during the sprint. We can meet in the breakout room in Discord.
All right.
Just outside. Okay.
you so much.
Thank you.